welcome back to my YouTube channel. Now we are going to discuss about chi-square test for independence of attributes or else contingency table we can call it as. Okay, R cross K or 2 cross 2. Okay, so this is the most important question for semester 4 in unit 3. Okay, so now we'll see what it is. Okay, so you all know that attribute in the sense which refers to the qualitative data, not quantitative data, qualitative data. Okay, so now we'll see. Let us suppose that the given population consisting of capital N items. Okay, capital N in the sense what? Population sample size. That means, sorry, population size, not sample. Population size is denoted with capital N. Is divided into A1, A2, and so on, AR with respect to attribute A. Okay, so this is called as attribute A, which is divided into R sample points. Okay, next, similarly, let us suppose that same population, that means the same population is divided into yes mutually disjoint and exhaustive classes, nothing but B1, B2, and so on, BS, with respect to another attribute B. Okay, so there are n points. The size of the population is n. This n is divided into two attributes. One is A1, A2, A3, and so on up to AR, and the other is B1, B2, B3, and so on up to BS. Okay, na? So now we represent R cross S manifold contingency table. Okay, so now we represent R cross S manifold contingency table. Contingency table in the sense nothing but rows and columns which consist of. So A, this is attribute A. So A1, A2, and so on up to AR. Okay, and next is B. B1, B2, and so on up to BS. Okay, so here this two intersection point is A1, B1, and here is A1, B2, and so on A1, BS. Okay, so in the same way A2, B1, A2, B2, and so on A2, BS. Okay, so on, and the last one is AR B1, AR, B2 and so on, AR, BS. Okay. So this is called as contingency table. Okay. So now total. If we want attribute A1 value, if we add all these attributes, we'll get attribute A1. In the same way, attribute A2 and so on, attribute AR. And the next is attribute B1, this total. Okay, column wise and row wise total. And this one is B2. And so on, if we add this one, we'll get BS. Okay. So this is capital N, that means overall total. If we add this side, you will get this one. If you add this side also, you will get the same answer. Okay. So this is called as overall total or else population, we can call it as. Okay. So now let AI is the number of persons processing or possessing, we can call it as processing the attribute A. The attribute A. In the same way, BJ is the number of persons processing or possessing attribute, possessing the attribute B. So if we write AIBJ, that means what? The number of persons possessing or processing both the attributes A and B. Okay, both the attributes A, I and BJ. Okay, so now what we have to do is, now we'll set up what is null hypothesis. Okay, so if we want to do anything, we have to follow hypothesis steps. The first one is null hypothesis. Till now we have written the introduction part. Now null hypothesis. Null hypothesis. Null hypothesis. Here we have to consider attributes. The two attributes are independent. That means they don't depend on one another. So the two attributes, why? Because the process itself is testing the independency. So that's why here we have to consider the two attributes are independent. The two attributes are independent. Independent. So that means what? AI Bj H naught such that AI Bj equals to AI Bj naught. Okay, this is null hypothesis. And alternative hypothesis, what we have to consider? Alternative hypothesis. Alternative hypothesis. The two attributes are not independent. Not independent. That means what? H1 such that, why? Because H1 in the sense alternative hypothesis denoted with H1. H1 such that AI Bj not equals to AI Bj not. Okay. So now if aibj not denotes the expected frequencies, the expected frequencies, then aibj equals to attribute ai into attribute bj by capital N. Okay. So this is the formula for what? If you want to get aibj value, we have to do this formula. Okay. So and the next is, now what we have to do is expected frequencies. So we have denoted this as expected frequencies and we have written the formula. So now we have to set R cross S observed frequencies. Observed frequencies. So that is aibj. And the corresponding expected frequencies, these are observed frequencies, and corresponding frequencies are nothing but, and the corresponding frequencies are nothing but, here itself we have denoted. Okay, ai bj not. Okay, so now applying chi-square test of goodness of fit. So goodness of fit is nothing but, here both the values, observed and expected values, will involve. Goodness of fit. The test statistic is chi-square equals to double summation. Why? Because here two attributes are involved. So double summation I j ai bj minus ai bj not. That means observed minus expected whole square by expected. Expected in the sense what? ai bj not. Okay, so this summation belongs to both the numerator and denominator. Okay, so this is observed expected by expected, nothing but. Similarly we will write in goodness of fit ai minus ei whole square by ei will write now. So here we are taking attributes now, so that's why in place of oi we wrote this attribute. Why? Because this is attributes now, so that's why. Okay, so now this follows, the above formula follows chi-square distribution with r minus 1 into s minus 1 degrees of freedom. We all know what is degrees of freedom. Okay, so now conclusion. If calculated value the calculated value less than the tabulated value for r minus 1 into s minus 1 degrees of freedom. We accept null hypothesis. We accept null hypothesis. Okay. Otherwise, we reject null hypothesis. Otherwise, we reject null hypothesis. So this is very easy. So don't lose marks. Okay, it is very important. Mostly it will come for the exam. So hope you all understand this question. So if you don't understand, once again you see the video from the first onwards. Okay, so if you are newly watching this video, please subscribe for latest updates. uh, Share with your friends and don't forget to like. Okay, so thank you. Have a nice day.